Hello, all. Welcome to another episode of AWS Show and Tell, the Generative AI edition. And I'm joined by Bobby. And today we are going to be chatting about a lot of uh, fun stuff today. We are going to look at the demos in personalized healthcare, and uh, it's going to be entertaining. At least I got to see a demo in the background. So let's get started here, right? So, Bobby, do you want to introduce yourself as we get started?
Yeah, sure. Yeah, thanks, Anil. So my name's Bobby Kubor. I'm a solutions architect here at AWS, based out of Sydney, Australia. So my main role is within the public sector side of the business, and specifically around digital innovation. So I tend to work with any customers that might have sort of a unique challenge that requires sometimes a bit of prototyping or a bit of experimentation with emerging technologies. Now, that could be anything from IoT to machine learning, generative AI, or even all the way through to robotics. So it's a bit of a fun role, as you could imagine. I quite enjoy it. But yeah, that's essentially a bit about what I do here in Australia for the ANZ public sector team.
Yeah, and that's great to hear, right? So, the some of our viewers already know me, but if you do not, I'm Anil Nanminti. I'm a host of the Generative AI Show and Tell series, and today I'm not joined by Rob or Trevor. I'm doing the hosting myself, but I'm joining from New Jersey today. So, all the audience, whoever are connecting, let us know where you're joining from. We'd like to know where all it is here. And Bobby is joining from Australia, right? So, where in Australia, Bobby?
Yeah, it's a bit of a long way. Based out of Sydney, so one of the biggest cities here in Australia. There's a bit of rivalry with Melbourne here in Australia, but
Yeah.
obviously I think Sydney's better. But yeah, based out of Sydney, it's 11 a.m. here, so an actually reasonable hour. I'm not sure about where you are, Anil, but
Yeah, you can see the background. It's a little dark. So it's about 8 p.m. my time here in New Jersey. And I see people connecting from all over the world. I can see, um, you know, some folks connecting from everywhere. Like people are connecting from India. We're looking at people connecting from Colombia.
Colombia. Yeah,
Yeah,
right.
I don't know what's the time in the other side, of the world, but I see some folks, yeah, Colorado. So that's a good time, right? It's
Yeah,
probably in
right.
the evening there, Miami. So yeah, please let us know in the chat where you're connecting from, folks, as we navigate through the series and episode here. We'll chat more about that. Yeah, we're seeing people connecting from Louisiana. So yeah, put it in the chat, folks. And in today's episode, we're going to chat about healthcare, right? So generative AI and IoT in healthcare. Now, uh, in the past episodes, we've chatted about knowledge bases or DeepSeek, Nova models, other multimodal showcases, right? So today's is a little bit different. We're going to chat about IoT, and that's Bobby is a specialist in robotics. You might have heard about that. And if you did not check out his LinkedIn profile, go check it out. You'll see that Bobby has a robotic arm in his LinkedIn profile picture. And I want to know a little bit about that, Bobby.
Yeah, so I've got a bit of a robotics background and robotics interest. A lot of what I do here at AWS, one of my specialties is in robotics, and so I work quite closely with the robotics on AWS team based in the US. And that robot in that LinkedIn picture was something that we built and 3D printed here in Australia. So built it from scratch and got it running on cloud computing. So we actually built out a simulation of that robotic arm to be able to create computer vision capabilities. And turns out it's actually pretty hard to get a robotic arm to detect something and reach out and grab it. There's actually a lot more that goes into it. I think we just take it for granted as humans because it's pretty easy for us. But yeah, there was quite a bit of work involved in building out that robotic arm, both simulation and physical.
Yeah, I was assuming that we just have code deploy it to the robotic arm and it's going to work out just like how we do. But it looks like there is a lot involvement there in terms of making sure that it's working. And good to see that you've started that from scratch, right? So any robotic fans here in the crowd here that's listening in, let us know. As you're doing that, right? So, but yeah, I was always thinking that it's just as easy as deploying the code, and it's going to make the robotic arm magically work.
Yeah. Yeah, it turns out it's a lot harder.
Do you need to write the programming in like machine language, like assembly language, or do you have like C++ code out there that does that?
No. Yeah, so it's usually C++ and Python, but there is a fair bit of mathematics that goes into inverse kinematics and computer vision, so machine learning aspects. Yeah, there's quite a bit that goes into it. Maybe maybe enough
Yeah, maybe for
for
another
another session
episode, right?
another time.
Exactly, maybe for another episode. So let's get into the details today. So what are we going to demo today, Rob, on the generative AI, right? So we know IoT is there.
Yeah,
We
sure.
have. Can you speak about that?
Yep. Yeah, sure. So look, one of I guess this use case is actually based around some of the challenges that we have in Australia, and I think these challenges are pretty, uh, they're pretty widespread. So you see it quite a bit across the world where the population is aging, the global population is aging, and as a result, it puts some strain on things like aged care facilities. As well as, one of the benefits of living longer is that you've got more chronic disease within a population. So
Hmm.
the population tends to require more healthcare services. Um, so, one of the challenges that we're looking at addressing is how do we start to apply technology to some of those challenges to be able to reduce the amount of administrative burden for clinicians and healthcare professionals. And one way to do that is to be able to push some of this technology into to be able to push some of this technology into people's homes, so that people are able to continue to age within their home or receive medical treatment within their home without necessarily needing to go to a facility which is already burdened with a considerable number of patients. So the demonstration, what we're going to show is how we can utilize IoT technologies to provide unobtrusive monitoring
Hmm.
of people that may have certain conditions or may be living independently as a senior. But keep in mind that a lot of this IoT technology produces a lot of telemetry. It's quite
Hmm.
noisy, especially given we're only going to be looking at one person here today. But if you were to do that across multiple people, across an entire population, that's a large amount of data that we're producing. And for clinicians to be able to go through that data and find information, they don't necessarily have SQL skills. So what we're able to do is utilize generative AI to begin to understand that data at a large scale. So that's essentially the demonstration that we're going to be showing today.
Right. So it looks like we will have some simulation of you know generative AI, IoT, and yeah, if you want to bring up the demo and show it to us, let's start there and then talk about the
Yeah,
technology
sure.
behind the demo.
Cool. Is my screen? Yeah, my screen's visible. So look, there's a couple of different technologies that we're going to show here. From an IoT perspective, we're using wave radar. It's effectively a way to be able to determine where someone might be in a room as well as what pose they're in. So it effectively uses radar, which humans are highly reflective of, to be able to determine that person's XYZ coordinates. It's great for being able to determine where someone may be within a room and what pose they might be in. So if they've had a fall or if they're in the bed, if they're on the ground, if they're in a chair, that sort of thing. So being able to start to understand, if someone might be socially isolating themselves because they haven't left the house and no one's come past. The other sort of IoT technology that we're going to be looking at as part of this demonstration is effectively wearables. So being able to collect physiological data from someone who might be living independently. So maybe they're wearing a continuous blood glucose monitor, such as what
Hmm.
we've got in this demonstration. So what you can see in this demo, top right-hand corner, you can actually see a live view of myself moving into a room. Top left-hand corner, you can see a digital twin. It's built in AWS IoT Twin Maker. And you could see that room light up as I moved into that room. So we're able to quickly reflect changes in a scenario within a real environment. As I get into that bed, you can see that the bed has lit up with a person inside that bed. It's a green person, which reflects their blood glucose. So it's at 80 mils, which is a standard number. So it's within the healthy range. We've artificially dropped that down to 40 mils, which then reflects an unhealthy range. So sort of the main point here is that we can quickly reflect the data that's coming in within a visual element. And as we come out of the bed, you can see that the bed entry, bed exit, sleep duration times have changed as well. So once again, quickly reflecting more than just where the person is in the room, but if they've slept, how long they've slept for, if they're having disturbed sleep. You can see there my terrible acting. I've fallen over. And then in the digital twin, the room turns orange. So the effectively what we're doing here is going into a bit of a holding pattern, where we're waiting for about 45 to 60 seconds to see if the person gets back up. If they don't get back up, we look to raise an alarm of some sort. If they do, then we cancel the alert, and we might send a notification to a carer to potentially check up on that person the next day. But if this person doesn't get back up, then we're able to raise an alarm, we're able to issue a notification, potentially use something like Amazon Connect to be able to call out to a carer, and be able to get immediate assistance. One interesting thing to note here, so we actually had some interns come through here earlier in the year, through the AWS office. They actually built out a further capability in this demonstration where they actually had a robotic device, so a robotic quadruped,
Hmm.
essentially a robot dog, that was able to autonomously navigate to the person that's fallen over, and then be able to initiate a call through Amazon Connect to the carer. And then they were able to communicate with an AI agent. So the carer would be able to say, does the person look in distress? That would then be converted from voice to text using the open source Whisper model on SageMaker.
Hmm.
Um, that question would then be posed to the robotic device, which would be using the video footage that it's collecting, to be able to determine, using once again generative AI, using a multimodal model to be able to determine if the person visually is in distress, and then be able to respond back, text to voice. So starting to really push the boundaries of what this could look like, with potentially very little human intervention. So, what could this look like in the next 5 years with robotic devices in people's households, being able to perform these sorts of checks and balances?
I see that we have a number of items that you're showing us. One is you spoke about millimeter radar that you've used,
Yep.
um, and then we're looking at. I mean, that's IoT device connected to the. Is it connected to what service is it connected to on the AWS side? Maybe let me
It's
ask that.
connected to AWS, yeah, AWS IoT Core. So it's
Hmm.
effectively sending a payload once every 5 to 10 seconds. So it's near real time in terms of being able to provide an understanding of where that person is and their pose. Um, as you could imagine, that can get pretty noisy pretty quickly, right? That's a lot of data coming in. And certainly, this is where you start to see the benefits of generative AI, around being able to ask those questions. Because as you could imagine, like what you're looking at here, while it's great from a visual perspective, no one's going to necessarily sit here and watch me walk around a room for 24 hours a day. Usually, that data becomes extremely useful, either to detect a potential incident that may occur, or to be able to investigate an incident after it's occurred. So, if you've ever fallen over, and or if someone an elderly person that you may know has fallen over, when they go to get treatment or when they go to hospital, that clinician then needs to try and work out why they fell over to ensure that it doesn't happen again. With
Hmm.
this sort of technology, we can start to understand cause and effect, but it is a lot of data to have to process and navigate through.
So yeah, I mean that's good to know, right? Because we obviously we don't want to have cameras in the bedrooms sometimes, right? So
Exactly.
the millimeter radar waves are going to detect the person, and you're showing how it detects the exact location of the person within the room, and uh, putting that in the digital twin, right? So how did we build the digital twin here?
So this digital twin, admittedly, doesn't look exactly like my bedroom. This was
Close enough.
actually built out. Yeah, this was actually built out before generative AI models. Before the sort of advent of generative AI models that could build 3D models.
Hmm.
So what you can see here. I'll just rewind a bit so it's not yellow. But what you can see here are just some models that are open sourced that we've just placed in the room. These simulations are actually really difficult to build. They can take a considerable amount of time to find all the bits and pieces and put them in. We're actually seeing people accelerate the generation of these simulation environments using generative AI to create these 3D models. So you can say, I want a bed that has a red bed sheet and a white pillow. It needs to have
Hmm.
a bed head. Um, Create it for me. And within 60 seconds, you could have a 3D asset that you could pull into your environment. For things like robotic simulation, like being able to produce these simulated environments, really important. They just take a considerable amount of time. So we're starting to see the acceleration of this. But yeah, this took me a while to create, hand carved.
Right, and then we're probably getting closer to AI building code for us, right? To build these kind of simulations and bring this as close as
Yeah.
possible to the real bedroom, or maybe the whatever place it is, right? So now now that we have the millimeter radar putting the digital twin and sending data near real time.
Hmm.
You also mentioned about being able to gather the health information, the vital details, right?
Yep.
So now we are gathering the vital details using probably some SDK that's available to capture those details, and then streaming them to AWS, right? So how are we streaming it
Yep.
into AWS at that point?
More or less the same way. So once again, using AWS IoT Core
Mhm.
as the endpoint to ingest a lot of that telemetry. Um, Through that, we're able to do a number of things. So potentially using traditional machine learning to look for anomalous events on the fly. So an example of that may be that the person is in bed or hasn't gotten out of bed in the morning um, at the same time that they usually do. That could
Mhm.
indicate something that requires investigation. So, being able to use something like Apache Flink with Amazon Kinesis allows us to be able to look for those anomalous events on the fly and then be able to alert on those anomalous events. But otherwise, the data does end up landing within. So all of this data, I'm actually landing in S3,
Okay.
and then placing a capability over the top. And I'll actually just bring that into the window so you can actually see. But what we're doing is we're pulling all of that data into Amazon S3. We're cataloging it using AWS Glue. And then we're able to start asking those natural language questions of that data. Is that something that, did we want to take a look at that now?
I think we want to zoom in. Yeah.
Yeah, okay, cool. So look, as I mentioned before, really difficult for, I mean, my SQL skills are terrible. The best I can do is select star from table, and that's about it. And I sit there and scroll through all the data until I find what I need. So being able to do things like writing a natural language question being able to have that question, effectively being able to provide a machine learning model or a foundational model, an understanding of the data that I actually have. So providing it a data dictionary, for example,
Hmm.
and saying, this is the data that I have. This is the natural language question. Write a SQL query to be able to query my data set, return the result, and then provide a natural language response based on that result is effectively what we're doing here.
So this
So
is
just
all
to give,
generative AI, right? So this is where
this is
generative
all
AI comes into picture.
exactly. Yeah, exactly. So what you can see here is Amazon Bedrock's console. Specifically, we're using the agents for Amazon Bedrock capability. And we're asking the question of, were there any abnormal glucose readings for the night of the 7th and 8th of July 2024? So as you remember in the demonstration, there was a drop in blood glucose
Hmm.
for our patient, which happened to be myself. We're looking in the debug logs here because I want to show what the rationale is, what the foundational model is actually doing. So it's saying, to answer this question, I will need to query the appropriate table to find any glucose readings that were recorded for the patient. I will look for any readings that are outside the normal range for glucose levels. As we continue on, you can see there that it's written the SQL statement. It's better than anything I would write personally. Certainly a lot more complex than anything I could write. You can take a look here. It's executed that query, pulled back all of that telemetry around the glucose values between those time ranges in a JSON payload. And then if we go back to the chat, it's actually used its capability. The foundational model has used its capability to provide a natural language response. So based on the glucose readings returned from the query, there were some abnormal glucose readings for the patient between 239 and 242. You can see here the low glucose readings ranging from 55 to 39 mils. They're below the normal range. Indicates that Bob may have had a hypoglycemic episode during that period. What's really interesting about this is as we continue on, because we're using memory. So any questions and answers that have been asked are stored in memory, and we're able to ask subsequent questions. It takes those previous questions and answers into consideration as it continues on its way. So here, I can't even remember what the question was. Yeah, what time did Bob fall on the same night? So, potentially if we're a clinician, we might be looking for a correlation between those low blood glucose levels and if that person has had a fall. To find out if Bob had any falls on the same night as the abnormal glucose readings, I'll need to query the appropriate table once again.
So, so now actually, like I would like you to pause for a second, right? Because imagine like a healthcare
Sure.
technician trying to understand what's going on here, right? So first of all, just to understand the blood glucose level, there is a lot of manual work that's required, right? So and even with all the real-time monitoring, if you have those health devices that are uh, sending all the vitals, being able to correlate all the information and putting it in one place and finding like and asking normal natural questions, right, natural language questions as to what is the glucose level, were there any abnormalities, not knowing anything about the database. I mean, there are a number of things that you're showing us to all the viewers here that uh, will actually kind of take healthcare to the next level, right? So essentially, this is probably how the future of healthcare is going to look like, where you don't want to worry about what are the databases. So the question can be any kind of question out there, right? So you were
Yep.
asking about abnormalities, and you could probably ask about, hey, maybe show me other kinds of data that the patient has and correlate that with the fall, right? So being able to get the health reports for the patients and then correlate them and essentially bringing the data and looking at and this screen here. I know you're showing all the backend of what's happening, the SQL, the database query and the responses, but yeah, it's like a lot happening here in a matter of
Mm.
couple of seconds, right? So this is all, if it were to be analyzed, all of this would take a lot of time, and all of this is
Yep.
quite important from like a central healthcare facility that's probably monitoring a number of patients. to be able to zoom in and understand what's going on with a specific patient that needs alerts or some kind of urgent treatment that's out there.
Yeah, exactly. And one thing to note here is certainly we're not suggesting that this is a medical device or that you would be able to make, clinical decisions based off exactly this information. But what it really provides is an aid to be able to make quick decisions, intelligent decisions. Certainly, you always, with healthcare, you always want a human in the loop. You always want to ensure that you are able to validate any output that is produced.
Hmm.
But it really can accelerate a lot of that investigative process, right? And what we can even see when we're taking a look is that it does start to build correlations. So, an example here is according to the query results, Bob experienced a fall event that was detected at 2:39, was confirmed at 2:40. Interestingly, here it starts to pull in the information from the previous question. This fall event occurred very close in time to the abnormal glucose readings that were observed for Bob between 2:39 and 2:42. It starts to make a correlation. The low glucose levels likely contributed to or caused the fall that was detected and confirmed during that time period. So, in summary, Bob experienced a hypoglycemic episode with very low glucose readings, which then led to a confirmed fall event just a short time later. So, you can see how this sort of technology can provide a good understanding of what could have potentially happened. Once again, as a healthcare professional, they would need to confirm that this is exactly what had occurred.
Right.
But how quickly you can put together that information, especially when time is a factor within healthcare, then this is a pretty good aid to be able to be able to ask those sorts of questions.
Right. And being able to correlate different uh, data that's out there and putting it all together in one place, right? So uh,
Mm,
while you're looking at, I mean, details here, while you're showing us the details about the fall, knowledge bases, right? So can we speak about
mm,
knowledge bases and S3? What does it take to actually integrate a knowledge base with S3, right? I mean,
yeah.
maybe you can chat about that with our viewers who are listening in. Um,
Yeah. So interestingly, the type of data that we're looking at here is different from what we traditionally see with knowledge bases, which tends to be free form text. In this case, obviously, we're using structured data, we're using tables. At most, it may be in JSON format, so it may be semi structured to some degree. So there is within the knowledge bases capability that Amazon provides, you can use structured data now as a data source within the knowledge base. So you can say that you want to point this capability at able to ask those same questions. But the additional thing to note here, we actually did do so. One of my colleagues, Manuai Korba, he did open
mhm.
source this sort of capability, which I think I've got up on another window. Natural language questions Gen AI chatbot for structured data on the AWS samples repo, which you should be able to see here. Um, this actually uses Amazon Bedrock with LangChain to be able to ask these sorts of questions of any database engine, whether that's a federated engine via Amazon Athena, whether that's Postgres, MySQL. It provides a nice interface in Chainlit, which you can sort of see here. But in addition to this, what it allows is the ability to start to chain together some of these capabilities. So, as an example, as you sort of mentioned, you can use this sort of pattern with any types of data, whether that's healthcare related or what you can see on this screen. Oh, the lights went out in this room. That's not good. There we go.
Okay. Yeah.
So yeah, what you can see on this screen is wind farm data, for example. You can start to ask questions around, which wind turbine potentially had, if I put in here, let's just renew this. So we can ask how many turbines are in the database and what are their asset IDs. Once we get a response from this, maybe we want to ask a subsequent question, which is which of these turbines has had the highest average temperature and what was it? What we can start to do is if we notice that this is anomalously high, we can then start to pass these answers to another part of the chain to ask Amazon's knowledge base capability, which may have wind farm instructions or wind farm maintenance operators guides. Based on this answer that I've got, what actions should I take to remediate the situation, right? So we're able to start chaining together different sorts of capability. So ask this structured data repository a question, take the answer to that, ask this knowledge base what I should do with it, collect that information back, maybe go out to the internet and look for a response there, come back, provide the answer. So we're starting to see the ability to chain all of these capabilities together.
So if we talk about agents, right, which is getting together um,
Mm.
all of these tools, maybe we should call it that way, right? So all the tools, being able to search the internet, being able to get to the knowledge base, being able to understand maybe some details about other systems that are integrated here. Agents are doing all of this tool calling and being able to do some reasoning based on the reasoning models that are provided and
Yep.
understand the plan of action so that the sequence can be followed,
Mm.
right? So
Yeah. What I love about this is the ability to utilize different models. So Bedrock now has a marketplace. So I could potentially use a model that's really good at generating SQL queries. But then
mhm.
once I've got that telemetry, so once I've got a table full of blood glucose levels or vibration data from a wind farm, I can then pass that to a completely different model that's specialized on wind farms or blood glucose or medical information. And then I can pass that to another repository in knowledge bases that has information on remediation. So, yeah, being able to start to pass this information now, there is still a bit of friction between passing information from one system to another. You do need to ensure that it's in the right format at times, but when it works and when you've put it all together, it really is amazing what sort of stuff you can put together.
Right. And in terms of this Lang graph that you're using here, um, can you speak a little bit about Lang graph and how this fits into the demo that you built?
Yeah, so look, with regard to what we're actually utilizing here for this demonstration, slightly different to the demonstration that you saw before in terms of the underlying technology.
Hmm.
Mainly because the demo that you saw before was built in early 2024. This demo was built late 2024, and the industry moves so fast, right? It's by the time this finishes airing, there's going to be something else. So this will all be redundant. But I feel like I'm just constantly chasing my tail with some of this stuff. But one of the great things that's available for LangChain and LangGraph is some of the tooling that comes out of the box. So, as an example, the tools that are available for SQL. To give you an idea, when I've asked how many turbines are in the database and what are their asset IDs, you can actually see within this interface the steps that are taken to be able to execute the query. So you can see the agent that's executed, the tools that it's using. Here we're using SQL database list tables where it's listing all of the tables. We've only got this one table. It's actually doing this in Glue. After that, it once again executes another tool, which is the SQL database schema. So
Hmm.
it's looking to understand what is, if we take a look a bit lower, it looks to understand the columns that are available and if there's any descriptions of those columns. Before, if we scroll a bit further down, we take a look at this one, it's then able to execute the SQL database query um, based on the information that it's collected prior. So, what's really cool about this is you can jump from database to table to, and it doesn't necessarily, it could be like a data lake using Amazon S3 and Amazon Athena. It could be Postgres, it could be MySQL. It makes it really easy to just jump from database to database, model to model. Makes it really easy to chain stuff together. It's a really good framework. And we've been able to use LangChain and LangGraph specifically on AWS Lambda, right? So you don't necessarily need to spin up compute to be able to use these sorts of capabilities. You can just integrate them into your Lambda functions and call them in an event-driven manner.
Excellent, right? So you've shown us how agents can be used to make tool calling and get data from different data sets. In this case, now what next year, Bobby? I know that
Yeah.
going back to the demo. I mean, there is like a cool UI that is out there, like in the patient healthcare. How does how does this all come together, right? So.
It's a good question. Look, I think one of the challenges for a lot of healthcare providers is the hardware element as
Mhm.
opposed to necessarily because this stuff is, it's scary how easy it is to set up now, especially with being able to just ask a model to write you the code to execute. It's now getting to a point where it just works on first go. So it's, the software element and being able to do this stuff isn't necessarily the complex part. It's being able to collect that data, and this seems to be a recurring conversation with a lot of customers. Your capability around generative AI is about as good as your source data is. So if you've got a great data source to be able to leverage and use,
Mhm.
then it's quite easy to build this capability on top of. So really, for a lot of organizations, it's going to be about making sure that you're able to collect that data in the first place.
So are you saying that gone are the times that it takes to build all these complex software-based applications that
What's yeah, what's
a- a-
crazy is about 50% of my job is prototyping, and yeah, I can now pump out probably 20 times the number of prototypes that I was previously doing in previous years, just because of how quickly you can get code written.
and nowadays I think that they're also calling this as a vibe coding,
Vibe coding. Yeah, yeah.
right? So
I'm not
being
sure
able
I
to.
I'm not sure I feel that. I'm not sure I like that description, but
Yeah.
yeah, it is. Yeah, I hear that quite a bit. And look, I'm not necessarily certain I'd want to put code straight into production. That's come off the back of a chat interface. But I tell you what, for prototyping and being able to showcase what's possible, it's so quick. It's so quick.
Right, yeah, and I'll let's get your demo back up again, right?
Mm,
The first one that you have out there on the healthcare, right? So here we are looking at the correlation of the data,
yep.
and what else do you have there? I see that do you have more of the demo?
Not really. So it essentially does go. I do ask a question of when did Bob get in and out of bed. It just finds more correlations, but it's not necessarily anything new. So
Hmm.
it does suggest that it does start to paint that full picture that Bob went to bed at a specific time, remained in bed throughout the night. We're getting records every 5 minutes in this specific case. Got out of bed at 2:38. It starts to build out exactly what happened with when he went to bed, when he got out of bed, when the blood glucose dropped, and when he fell. So starts to paint that picture. But once again, similar sort of setup and use case.
Right, right. So now we're talking about the convergence of IoT, digital twins, generative AI to make healthcare, new avenues of healthcare possible. Right. So
Yeah.
being able to collect and stream the data. Um, Now, how? I mean, I would ask you, n- outside of the digital twin that you said it took some time, like what was the build time that that had actually
Yeah.
taken to build all of this, to put all of this together?
Um, so interesting manually, because back then this would have been early 2024 when I wasn't necessarily using generative AI to write my code. It probably took about a week, honestly. And a lot of that was fiddling with hardware, trying to get the
Hmm.
hardware to work. And why doesn't this work? I need a certificate. It's self-signed, so so there was just a bunch of work in fiddling with a lot of hardware. But the actual putting together, and admittedly, I used a lot of existing scaffolding. So that graphing capability that the digital twin is embedded into, which I'll just bring up again so you can see. So this whole graphing interface is actually Grafana, managed Grafana on AWS. So pretty easy to spin that up and start creating the boxes and correlate it to the data that's streaming in from the IoT devices. So admittedly, it really didn't take too long at all.
All right. So now, in terms of that, the bar there, the graph, and the the details over there, are you correlating
Yep.
any of the generative AI over there, or is it straight out of the data set that you're pulling out?
This is all straight out of the data set that we're pulling out. So once again, it's one of those things where I don't think necessarily anyone would sit there and look at a dashboard
Hmm.
24/7. And some people might find it overly intrusive that you can figure out where they are in their house at any point in time. So it's probably more from a demonstration standpoint, how quickly you can reflect that telemetry. Um, but yeah, it's more just
It's the
showcasing
art of the possible,
the
right? So you're able to show the art of the
yeah,
possible that the details are coming from the millimeter radar that's
yeah,
able to capture that level of details.
yeah.
Um, Now, in terms of being able to correlate all of that, and you've spoken about Amazon Connect.
Mhm.
Um, uh, so how does Connect fit into all of this, right? So,
Yeah. So let me show you a quick screenshot of something that we were working on, and this is coming back to what I described a bit earlier. So hopefully you can see a screenshot there. Can you see
right.
that screen? Yeah. Okay, cool. So this is, as I described earlier, a robotic dog and this actual screenshot here is actually a screenshot from a simulation engine running NVIDIA Isaac,
Hmm.
NVIDIA Isaac Sim. We're running this on a G6 EC2 instance, so it does need a fair bit of GPU to be able to run what is effectively a photorealistic simulation. So, being able to build out an environment that is actually extremely realistic in terms of if I was to actually take you through this virtual hospital, it looks like a real hospital. And it's
For a
you see
second,
the
I thought that was a
reflection
real
of the
image.
light.
I thought that
That's
the
right,
robot
right?
was,
Like,
yeah.
yeah, yeah, and it's unreal. Like, so I've been doing simulations for a while in robotics, and this is next level to the point that you can train computer vision models
Hmm.
within these sorts of environments because it's so photorealistic. You can even see the reflection off the ground
Yep.
from the lighting. It's unreal. So this guy here, he's meant to be someone that's fallen over. It looks like he's just taking a nap next to the vending machine. So it was the best that I could do. But essentially, he's meant to be a guy that's fallen over, and we've got this robot dog that's navigated to him.
Hmm.
Now, this is all part of being able to create a capability that has an autonomous robotic device that navigates to this person here, notices that they're on the ground, and then initiates that outbound call. So it's able to do that by invoking the Connect API to be able to make that outbound call to a carer, to someone who might be of a nursing function that might be on call, and then being able to begin a voice call with an AI agent. So the effectively the robotic dog is, think of it like an AI agent that is able to relay answers to questions that the nurse may have. So is the person on the ground? Are they unconscious? Do they have their eyes open? The robotic dog is able to pull all that information from its computer vision, and be able to answer all those questions over a phone call. So that's where that connection comes in.
Yeah, the robotic dog could get all the details, all the correlation, put that together, and then with that correlation, take that information. Right. Again, we're
Yeah.
seeing comments in the chat saying that it's an interesting chat. And look at this one. I don't see the user. It shows LinkedIn user, but it says next generation. Crazy.
Yeah.
It's this generation, right? And Bobby just
It's interesting stuff where this could all go, and we are seeing, like, there are certain countries around the world where they're really pushing the envelope with this sort of stuff around robotics in healthcare. Japan and Singapore, for example, you're starting to see the advent of robotic nurses to be able to augment the human nursing function. So
is that right? Okay,
um, yeah, it's unreal where things are going, and it's great to see tech being used in for this sort of for these sorts of use cases.
excellent. Right. So I mean, definitely this is next level stuff that we're seeing here, including the simulation itself. Right. So great chat there. Now, what's next for you out there, Bobby? Like, what's your next project? Or are you extending more on this project?
Right, it's a hard one. So I'm regularly involved in builds across different verticals of public sector. This is probably one of my more favorite ones because it does have an element of everything, really: IoT, digital twins, generative AI, traditional computer vision, robotics, the works. So this will continue to be built out. Chances are I'll probably be back on this channel, in 3 months' time to actually show, because we've got that physical robotic dog. So we'll probably be able to show a live demo of exactly how it would work. As I mentioned before, the interns that were working with us managed to get a pretty scrappy version working, and it did work. So being able to really start to polish that and be able to use that across different industries, because as you could imagine, like, that sort of use case is also important in utility. So maybe there's somewhere that is dangerous for humans to go, but an asset that is within that location needs to be inspected. To be able to send an autonomous unit in to then be able to use computer vision and generative AI to provide information on what it sees. It's the same sort of use case, same sort of pattern. So looking at being able to take these sorts of capabilities and understand where they might apply with the different industry use cases.
Right. And we have a question in the chat, and I don't know the answer for this one. Maybe you know that. Can robots lift humans? Right. So I don't know the
It
answer for
depends
that.
on the robot. It depends on
Okay.
the robot. Yes. So this one definitely couldn't, unless it was my child, who's 2 years old. So my child could probably ride it like it was a horse. But there are definitely robotic devices that are able to carry really heavy payloads. They're considerably more expensive than this one in this picture. But and I mean, this hardware is just generally pretty expensive, so it'll be a while before we see the costs really come down for consumers to be able to buy. We're already seeing talk of that in the industry. But yes, there are definitely devices that could handle 200-pound payloads. They're
Right.
going to be big devices. That's the problem.
And also the next question is from me is where do you see healthcare going from here? Right, taking advantage of
Mm.
all these different options available, generative
Yep.
AI, the tool sets that are available. Where do you see this going?
I think There's a couple of different aspects to this. One is definitely, collecting and cleaning data is really the biggest challenge here. The other is an understanding of where this technology is a good fit within healthcare. So once again, um, this sort of technology great for being able to provide power to the clinician or power to the healthcare professional to be able to do things much quicker and be able to produce outcomes and be able to cater for more patients quicker. But once again, it's not necessarily a it's definitely not a medical device, and it doesn't replace the clinician. It doesn't replace clinical decision making that the human still needs to do. So I think there's still an element of ensuring that there's a clear understanding of where this technology plays a role within that industry and where it's safe and where you want to ensure the safe use of this technology. So ensuring that there is a human in the loop appropriately. But the second element is, yeah, that data collection. Once we've started to get around some of those challenges, I think we'll see much more of an adoption. And certainly, we are starting to see an adoption within healthcare of this tech, but it's a cautious adoption, and so it should be. So it's exciting times, but we're just at the beginning of the journey, I feel.
Beginning of the journey, we are also seeing different capabilities of the agentic um, usage evolve, and the new patterns, supervisor patterns, swarm patterns, being
Mm.
able to have one agent give handoff to another agent, right? So we are seeing the whole lot of things evolve, and it's just the beginning of this, right? So with that said, again, for people in any viewers out there, if you have any questions for Bobby, put them in the chat. But other than that, this is a great demo. Like we're looking at a, a full solution here utilizing generative AI. In the previous episodes, we were looking at different services and how to use the services and being able to correlate them. But thanks a lot for bringing and showing a great demo that correlates different services together, Bobby.
Yeah, no, happy to. Yeah, always happy to jump on and have a chat about what's going on in the world of tech and public sector.
Yeah, would love to see the next version of this coming up, right? So where you show us the live demo, or maybe a
Yeah, with the
simulation,
robot.
or maybe a realistic simulation of what's
Yeah.
happening there.
Or maybe I'll show you both, and then you got to work out which one's the real one.
See, that's still going to be a fix, right? So, but yeah, excellent. So, good to see all of this coming together. With that said, thank you all for watching another episode of the Show and Tell Generative AI edition, and see you the same time next week.